Welcome to the Python Crash Course. Today we will apply the knowledge from last week's session and we will look at real data. And even if you've never coded before, I will show you some basic grammar of Python and also follow the step-by-step guideline towards machine modeling model that you learned in the last session. And in the end, we will look at a real data set and have a coding project. So please stay with me and don't worry, even if you've never written a line of code, you will learn the basics in this session. What we are doing today is understanding the fundamentals of Python. So what is a notebook in the first place? What are variables and which types of variables exist? And we will also look into conditions, loops, and functions. And then I will introduce you to one of the most basic packages within Python. It's called pandas, and it's for handling low-dimensional data, so tabular data. And we will load, view, and transform this type of data. And then we will plot this data with another great Python package called matplotlib. And finally, we will pick up the step-by-step guide towards machine learning from the last session, and I will give you code examples for every single step in this process. So let's start right at the beginning. So it doesn't matter if you have never programmed before. I will try to start as easy as possible. What is Python? It's a general purpose language often used to conduct data analysis. The goals of this language are to be extensible, simple, and readable. So if you have never programmed before, in my opinion, it's a great choice to start with Python. And a main advantage of Python is there is a package for everything. So that's kind of how Python is built up. You have the basic grammar, and then for whichever task you want to do in Python, you can download a package that fulfills your needs. So I will list now some of the basic packages that we often use in Python. So for data analysis, there is pandas and scikit-learn. For plotting, there's matplotlib and seaborn. For signal processing, there's scipy. For neurophysiological data, there's a specific package for that. That's called MNE. And then for deep learning, there are also different packages, Keras, TensorFlow, and PyTorch. We will not go this deep today in this session. It's just for you to know in the future. So let's look at Python. How do I use Python in the first place? So what you need to do is download a Python distribution. So that means you have to download a program which will run Python. This program, or one of the free distributions, is called Anaconda. And I put a link here, anaconda.com, where you can download this program. You can see the logo on the right side. It's like a green snake. And within this Anaconda program, you will find another program. So please bear with me for one more second. Anaconda is the Python distribution, and inside that there are different ways to use Python. And the most easy way for beginners is to work in Jupyter notebooks. So it's already pre-installed once you download Anaconda, and then you can locally work on your computer. So this is one way to access Python. Another way is Google Colab. It is an online Python distribution, and it's great for collaborating. However, it has some disadvantages in comparison to working locally on your computer. For example, if you work with data, then you need to either link it in the Google Drive or upload it every time you access a notebook. So there are pros and cons for each way of using Python. And the notebooks I will provide you with in this session work both in Google Colab and Jupyter Notebooks. So it's your choice. I personally use Jupyter Notebooks. And this is how a Jupyter Notebook looks like. very similar to how a Google Colab notebook looks like. In the top, you can open multiple notebooks and switch between them. And below that, you have several notebook options. For example, saving, copying a cell, running the notebook, restarting the notebook. And on the right side of this bar, you can see the kernel status. What do we mean by kernel? You can imagine the kernel like the machine in the background, which is running all of the calculations. And in order for your Python notebook to run, the kernel must be running as well. So you might have to restart the kernel sometimes if you run into an error. But in this top right corner, you can see the kernel status, if it's running or if something is wrong. Then once we go further down on this page, you can see a code block. So there's a little one on the corner. It says print my first Python comment. So this is one line of code. And the main feature of Jupyter Notebooks is that Jupyter Notebooks is organized in blocks. So you can collect many blocks and run them together, run them one by one. And it's easy to organize your code this way. And it's easy when you're a beginner and you run easy lines of code. So here is the very most simple line you could imagine. It's the command print, and then we have the round brackets saying my first Python comment. And when we run this block, you can see underneath the code line written my first Python comment. This is the output of a block. So everything you write into a block is your code. And when you run it, your output will appear underneath the block. Below that, you can see something written. So we see comments. Comments start with a hashtag and so on. This is text that is written within your notebook. And this text is called Markdown block. So similar to a code block, you can also create a Markdown block and write stuff into your notebook, which can help you to organize the notebook. Yes, underneath we see another code block, and under that we can see cell options. So here we can copy a code cell, move it, or add more code cells. So now you have a general overview how a Python workspace looks like. And let's dive into the basic grammar in Python. So one fundamental thing you need to know in Python are variables. Every variable has a name and a value and a type. And now we will look at those different types of variables, which are listed on this slide. And on the right side, so on the blue background, I always posted screenshots from Python that show you how these variables can be declared. What do I mean with declare? That means that you assign a name and a value to a variable. And what is very nice about Python is you don't need to define the type of a variable specifically, but it will implicitly already be clear which is the type of your variable by following certain rules, let's say. So, for example, the first line in this code block is age equals 23. So the name of our variable is age, and the value of this variable is 23. Because this is a whole number, we know that this variable is an integer. Because all variables that get a full number assigned are integers. So we don't need to define age is an integer and I want to assign the value 23 to it. No, we only have to pick the name and the value, and Python will know which type of variable it is. So in the second line, we can see another variable. And the name of this variable is grade. And we assign the number 9.2 to it. So this is a floating point number. And this type of variable is called a float, because it's not a whole number, but it has one decimal space. The third line is the name equals Ingi. That's an Icelandic name. And strings need to be written in quotation marks. So by giving the quotation mark, we indicate that this is the type string. So this could be any text in there as long as it is in quotation marks. And then below these variable declarations, we print each variable and see it underneath in the output. What we can see in the output is that when we print our variable called name, it will not have the quotation marks anymore. We will just use the quotation marks to declare the variable. Okay. Let's move on to Boolean values and none. Boolean values are variables that have either the value true or false. So Boolean values are truth values. And here we declare both possible truth values. In the first line, we have x equals true and y equals false. And you can see below how those look like when we print it. And then we have a variable type called none. This is basically an empty variable. So we declare z equals none. Here also the capitalization is important for all three of them. You need to capitalize the first letter for true, false, and none. You maybe wonder why would we need an empty variable. We sometimes declare a variable like that to fill it in later, to keep it like a placeholder. And let's move on to two bit more complex types. The first is a list. So you can see in the top, the name of the list is D, and it equals bracket open, bracket close. And this would be an empty list. And if we want to fill into this list, we could write d.append and then in round brackets write whatever we want to append. This could be a variable of any type. So you see that d is a type of variable that can collect different variables. Or we could, when we declare a list, already fill it with values. So this would be another option. E equals open bracket A, B, C, D, E, close the bracket. Something I would like to mention here is that the type of bracket you use is very important in Python. So the square brackets are typical for lists, and only square brackets will work here. The round brackets are typical for functions, and only round brackets will work there. So this is all part of the Python grammar you need to remember. But also don't worry. In parallel to this lecture, you will get a Python notebook with all of these code examples in there, and then you can test it out yourself and also reuse this code when you're coding something. Okay, and then here also our printing command gets a bit more complex, let's say. If we want to print the list E, for example, we can choose to only print the third element. But more on this type of accessing list elements later on. then there's another variable type which is called a tuple. And this one works similar to the list, but here we use round brackets instead of square brackets. So you see, only switching the type of bracket leads to a whole different result. And now what is the difference between lists and tuples? Lists are mutable and tuples are immutable. That means that once we create a list, we can still change it later on, but a tuple cannot be changed. Then there is another type of variable that seems very similar to a list, and actually we created based on a list. So in the example on the right side, you can see that we first declare the list with a name L, and we fill it with different values. And then we create a set that we call S here. And we write S equals set, open round bracket, L, close round bracket. That means we create a set based on the list L. And characteristics of a set are that every element only appears once, and they will appear in the right order. So if a set is filled with numbers, they will be ordered by the number. If it's filled with letters, it will be organized by the alphabet. The last variable type I want to talk about in this session is the dictionary. And a dictionary is declared with curly brackets. So we pick the name for the dictionary. Here I use the name my_dict equals, open the curly bracket, and now you can define multiple keys which each have one value. So for example, in this dictionary, we want to collect information about one student. And we can create one key that is called name, then a key called age, class, and grade. And you can see that we can use different variable types as values for these keys. And we separate those different keys and value pairs with commas. And in the end, we just close the dictionary with a closing curly bracket. And yeah, this is a very useful variable type. And you can see below how we print this dictionary. And we can also specify which key of a dictionary we want to print. So in the second line of the output, you can see that we print only the grade of this student. Good. So far, so good about variables. We have a quiz on variable types. You can either scan the QR code here or use the link in a video description. Now we will talk about conditions. They are used to execute code only if a condition is true. So we first look at simple conditions. Here we only need an operator. So in the simple condition, we try to find out a truth value. And you can see in the screenshot on the right how the condition in the first line is x equals 2. And above we can see that, yes, we defined x to be 2. Therefore, the truth value of this condition will be true. I hope that makes sense. Let's look at another example. In the next line, we have the condition x does not equal 10, which is also the truth. That's why our print output will be true as well. Let's look at a negative example. In the line below, we say print if x is print x greater or equal to 3. This is not the truth because 2 is lower than 3, and that's why we will print a false. So you can use different types of operators for this simple condition. This could be equal, not equal, greater than, smaller than, or greater or equal, or smaller or equal. And now you might wonder how we or why we need those types of conditions. They are very useful for if statements. And if statements are used to execute code only if the condition is true. So this way we can structure a code and define what we want to execute and what we don't want to execute. And here's a very simple example on how we could use an if statement. So this if statement is used to output whether a person is allowed to drive a car or not. And we first define a variable called age. And in this example, this age is 21. And then you can see there are 3 things we need to write this if statement. The first thing is the if itself. So we write if age is greater or equal to 18. So this is our condition that we're checking. Then we have to end the condition with a colon. And then we have to indent all of the code that is dependent on this if statement. So we need to move this line 1 indent to the right, and only 1. And so basically in the first part of this code block, we check the age of a person. If it's greater than 18, then we can print allowed to drive a car. And now this if statement could already be done. So this would be enough for if statement. But there's another useful tool in if statements, and it's called else. So in the same indentation as the if, so at the beginning of the code block, we can type else and a colon. And that means if this condition is not fulfilled, then please do this instead. So the else will now print whatever is indented in the line below, but only if the if is not fulfilled. So if you would change the value of our variable to, let's say, 14, and we would run this code block again, then our code would not execute the 3rd line of code, but would directly jump into the 5th line of code and would print is not allowed to drive a car because the age of this person is 14. Okay. So this is a very useful tool, if and else. And just to wrap up, we need the condition to build an if statement. Then we can use the if alone, but we can also cover the negative result of the condition and put an else statement in the indentation. If you would not put the else statement, then just nothing would happen if the statement is negative. So if the truth value is false. You will also test out if statements in the Jupyter Notebook. We both have the guiding notebook and also an exercise where you can test this out. Good. Again, the colons are important for the grammar of this if statement and also the indentation. Okay, next step would be Boolean operators. Boolean operators are used to make those if statements more complex. So this way we can have multiple conditions in one if statement. And for the AND operator, we need to fulfill both conditions to become true. And for the OR operator, we need to fulfill only one of both conditions to become true. Let's look at 2 examples. So for the AND operator, we now have two variables, which we will use for two conditions. The first variable is have license and age equals 21. And this person also has a driving license. And now we will set the if clause saying if the person has a license and if the age is above 18, then they are allowed to drive the car. Otherwise, they are not allowed to drive a car. So here you see that a person needs to fulfill both requirements to come to the result is allowed to drive a car. If they don't fulfill both, they will immediately go to the else code. Let's check an OR operator. An OR operator. So we again have two conditions. This time we have a different example. So one variable tells us if a person has technical background, and another variable tells us if a person has medical background. And then our if clause says if a person has technical background or has medical background, then fits requirements of the digital health master. The else clause here is if the person has no technical background and no medical background, then it does not fit. They do not fit the requirements for the digital health master. So you can see based on those examples when you should use and when you should use or. Okay, now a different but equally useful tool within Python. They're called loops, and loops help you to repeat code multiple times. There are different ways to use a loop. One of them is a while loop. It repeats code while an element is true. You can see an example for the while loop in the upper screenshot. So we create a variable and assign the value 1 to it. And then we start the while loop. And again here, the same rules apply as for the if clause. So we have while, we have a condition. This time our condition is I is smaller than 4. Then we have a colon at the end. And then everything that belongs into this while loop, so everything that we want to repeat, needs to be indented. So you can see that the next two lines are shifted to the right. That means that as long as I is lower than 4, we will keep printing I. And the second step in this code block is that we will increase the value of I by 1. That means the first time we enter this loop, I has the value 1. So it fulfills the requirement that it's smaller than 4. Then we print I, which has the value 1. So you can see in the output that there's a 1. Then we increase the value of I by 1. So now the value of I is 2. So we enter the loop again. We check if I is smaller than 4. It's still correct because it equals 2 now. We print I. Now you can see the 2. We increase the value of I. Now it has the value 3. We check the condition again. It's true again. We print it again. We increase it again. And now our I has the value 4. And this time we enter the loop and we do not fulfill the condition anymore. And this is when we jump out of the loop. Okay. But there's also another type of loop. And this loop repeats code for all elements in a list. For this loop, we need a list to start the loop. So here we define a list of cities. And it has 3 elements, Reykjavik, Selfoss, and Akureyri. And now we will repeat this loop for every element in the list, so for every city of those 3. And the grammar is similar. We start the loop with a for. Then we can come up with any word, actually. I write here now city, but you could also say X or whatever. So for city, in cities, now we need to use the name of our list. Then we end the statement with a column, and then we indent again all of the code that should be repeated within this loop. And the code that we repeat here is print let's go to, and then the name of the city. And now, the first time we enter the loop, the first element of the list will be retrieved, which is Reykjavik. So we print let's go to Reykjavik. Then we enter the loop again. The second element of the list will be retrieved, which is Selfoss. And we will print let's go to Selfoss. And the same will happen for the last element of the list, which is Akureyri. So these are two different ways to create a loop. Again, the grammar is important to make it work. Okay. And now we will look at functions. Functions are a very basic element of Python. So we can define our own functions. So it's like a code block that we can reuse several times and fill it with different variables. But I will explain this in an example. However, also know that we can also use functions that other people defined for us. So, for example, when we download those packages I showed to you earlier, these packages are filled with functions that other people wrote. And that is very useful. For example, you will find a function how to plot, or find a function how to load data. So we don't need to start from scratch here. But it's still very useful for you to know how a function is defined in case you want to define your own function. And what we need to define a function is the function keyword, which is def. Then we need to give our function a name. And then we use round brackets to define parameters of a function. But what are parameters? So parameters can be the variables we want to fill in or use within this code block. Then we end this code line, this definition of a function, with a colon. And then once again, all of the code that should be executed within a function needs to be indented. And this function that we create here is very simple. We call it the hello function, and it can say, hello, my name is. And the only parameter of this function is name. So maybe now you can get a better understanding what parameters are. So the code that is executed within a function is always print hello, my name is. But we can use this function to print different names. And below you can see how we call a function. So we want to apply a function. We call this function by writing the function name, writing round brackets, and writing the parameter that we want to fill in, and then define the value for this parameter. And this time we use the name Ingi. And when we call this function, we will get the output, hello, my name is Ingi. So you see, we don't need to repeat this code block, this printing code block again. And we could use now any name in this as a function parameter to print different sentences. Always starting with hello, my name is, and then the name that we fill in. So this is just a very, very, very basic example of how a function works. But it's to show you the concept. And of course, functions can get very complex. But yeah, you will also practice in the exercise how to create different functions. And great. This is how one of the exercises looks like. So you can see you have different blocks of Markdown that give you explanations. And below you have the code blocks, which I also partly presented to you here in the presentation. So I think the best way to learn this is just downloading this Jupyter notebook, going in there and testing out this code by fulfilling the exercises or just changing the code that exists just to try out how it works. And yeah, keep these notebooks safe. I still sometimes look into the old notebooks I got in my first Python course because that's how I remember how the grammar is needed. And I'm sure those will be very valuable for you in the future if you plan to continue coding. So that were the basics of Python. And now we will do a little switch. Now we will move on from the Python basics and look into how we analyze and transform data in Python. For this, we use a Python library that is called pandas. And one key element of pandas are data frames. Data frames are a two-dimensional tabular data structure. You can see an example right here. So it's just like you're probably used from, just regular tables. We have the first row with column names. Then we have columns and rows. And data frame is just a name we use in this package for this type of table. First, some info on how to import pandas. I know many of you maybe are not very comfortable with coding yet, and this little box of terminal window might look a bit frightening to you, but you can. If you have a Mac or a Windows, doesn't matter, it works in both. In Mac, you just type in terminal in the search bar, then this little black window shows up, and then you just type pip, that is a Python package installer, and then a space, then you type install, and then another space, and then you write pandas. And now the pandas package will be downloaded to your computer. And then you already did your first terminal command. If that doesn't work for you, you can also stay in your notebook that is open and then write a exclamation mark and then repeat the same code as here in the terminal window. It should do the same job. It's also explained in the notebook itself. And then once it is imported, this package, you can write within your Python notebook, import pandas, and usually we give those packages a nickname, let's say, just to access the package more quickly. And the common nickname for pandas is PD. So we write import pandas as PD. And before we can talk about how to transform data in Python, we first need to find out how to import data into Python. And the most common format to do this is the CSV format. That means comma separated value file. You can use any Excel file you have and export it as a CSV file. It's basically just a different representation of your Excel file. And the CSV files are easy to read into Python. So there is a function. As I said before, most things that you want to do in Python have already been done, and you can just use the functions that exist. And luckily, there is a Python for reading CSV files. It is called read CSV in the Python package. And you call this function by writing pd.read_CSV, open bracket, the round bracket, that's important, And then in quotation marks, you put the path name of your CSV file. Then you separate with a comma. And then you could pick an index column, but that's optional. The most important part is open the bracket, path name, and you could already close the black bracket. How do you know that this function exists? This was something that I was asking me at the beginning when I started coding. How should I know all of this? Most of these things no one knows by heart, or at some point you start learning them by heart. But when you use a package like pandas and you want to read a CSV file, then the most natural thing for a Python programmer would be to Google pandas open CSV file function. And then you will get on the pandas website, and then you will see which is the correct function and which parameters this function has. So the first parameter here is the path name, and another optional parameter is the index column. So yeah, don't stress about this. You don't need to know this by heart. It's, as always, Google is your friend. And I think the most important part of learning how to code in Python is learning how to Google. And Google the things you need to know to code in Python. You can test this out in your notebook. There will also be a data set that you can use in this notebook. And yeah, CSV is not the only way to read data into Python. There are also functions for other data types, just Excel or JSON, for example. The data set that is provided with the notebook is sleep data. So it has parameters over, I think it's 2 or 3 months of a person wearing a smartwatch. And there are different parameters in that data frame. There's the sleep duration, the sleep onset latency, the number of wake-ups during the night, the time spent awake, the time in light sleep, the time in deep sleep, and also the time in REM. There's also a date column that indicates on which day this data was measured. And all of these measurements come from Withings ScanWatch. And yeah, those are the files from one individual. And yeah, I will use exactly this data also in the following examples. Okay, so after we imported the data, the first thing we want to do is just look at the data. That's usually what I do when I import data, have a first look to see if everything looks fine. And you can either just type the name of your data frame. I called this data frame sleep. And if you add the function head, open bracket, close bracket, behind this variable sleep, then it will only show the first 5 rows. That can be useful if it's a huge data frame. So yeah, below you can see the first 5 rows of the sleep data frame. And we can see the index column date. That's why I added this parameter on the slide before. So all of the data points are sorted by date. And we can see the different columns that we have. Month, weekday, light sleep, deep sleep, REM sleep, time awake, number of awakenings, time to fall asleep, and the overall sleep duration. And that looks all good to me. Just for your information, the Withings ScanWatch exports the time measurements in seconds. So if we, for example, look at the first line and look at the column light sleep, then those are 15,840 seconds in light sleep on this particular night. Then there's a very useful function called describe. It outputs some basic statistics, including mean, standard deviation, minimum, maximum, and some quartiles. but it only does that for the numerical features. So when I apply this to our sleep data frame, I just type sleep.describe, open bracket, close bracket. We get an overview of the average duration in light sleep, deep sleep, and so on. And it's usually a very nice way to get a first feeling for your data. Then I will now introduce you to some operations on the data. So one of them is sorting. There's a function that is called sort values, and we need to define on which column we want to sort. So here we will create a new data frame that is called sleep_sorted, and we will create this data frame by typing sleep.sortValues. Then we open the bracket for the parameters. One parameter is called by. Then we say by equals duration. And then we put in the next parameter, which is separated by a comma. And that is ascending. So here we can decide if the sorting should be ascending or descending. So we say ascending equals false. That means that our sorting is descending. And now you can see that the night with the highest sleep duration was April 19th, 2023. And here we had a sleep duration of 53,000 seconds. Okay, so sorting is quite useful in Python. And the most important thing is to define on which column you want to sort. Now another operation, it's called projection. We use the projection to only look at certain parts of the data frame. We use square brackets for that, and we type in the square brackets which part of the data frame we want to look at. So we can, for example, use our sleep data frame, then make us open square bracket and close square bracket, and in between write the name of the column that we want to see. In this example, you can see that we only see the duration in the sleep data frame. We could also define a list with multiple column names and then put the name of the list in the square brackets. This would give us a subset of columns of the data frame. Okay, bit similar, but now we're talking about the rows, is the slicing. So slicing means we want to select certain rows in the data frame. And we select those rows by their index. So in the example, you can see sleep, open bracket, the colon 5 and the closing bracket. That means we want to see the first 5 elements of the data frame. So here's some grammar on the left. The n stands for the nth element, so you can type in any number instead of n. Select all rows until the nth element. Select all rows starting from the nth element. So that is meant if you type the colon afterwards the n. Or if we want to only select rows in a certain range, we can select everything from the nth element until the mth element. So for example, everything from the 5th until the 10th row, let's say. Here's some extra tricks. If you type a -1 into the bracket, then you will always get the last element of the data frame. And if you do a double column, that means that you select, in this example, every second element of the data frame. If you would use a 3 there, you would select every third element. And selecting the data by row in this style is called slicing and is very useful. Also, if you just put a single number, for example the 5, then you would just get the 5th element of this data frame. Okay, here are some advanced examples. Here we combine the projection and the slicing. So in the first element, we select the time to fall asleep on the 10th night in the data frame. So we only use one column, the fall asleep time, and we only use one single night. So we end up with one single value. Or another example, we use a list as an input for the projection. So we use 3 different columns, and this is duration, awakenings, and wake. And then we only use the last 3 elements until the end of the data frame. So it might sound a bit complicated right now, but you have the exercises to play around with this type of slicing, and I'm sure you will get a hang of it very quickly. Now we will try some filtering, and I hope you remember the conditions from earlier. So we can also use the square brackets to filter the data based on a specific condition. So just to freshen up our memory, a condition was using a variable and an operator and getting a truth value for this condition. So in this case, before we looked at conditions in the context of if statements, in this case we use the conditions to only show the rows where the truth value is true for a condition. So let's illustrate that with an example. On the right side you see that we have the sleep data frame, but we add the condition that only the rows where the duration is longer than 6, so longer than 6 hours of sleep, only those rows should be shown in the data frame. So this is one way to do it. Below you can see another example. Here we only want to see the column duration and only for the rows where the month equals to March. This way we filter our data to only the values collected in March. Very useful, I promise you. Again, this will be practiced in the exercise. Okay, we are almost at the end of these more and more complex operations, but this one I don't want to skip. It's called aggregation and it's really nice. We can use the group by option to group the elements in the list by a certain column. So for example here, I use the month for the grouping. So now the data is grouped by month and we can see the mean value per month. So for an aggregation, we need 2 things. We need the group by. We need to fill in the column that we want to group by, and then we need to add the aggregation function. I put some examples of aggregation functions here. For example, mean, sum, max, min, standard deviation, and this is super interesting to learn about your data. So now we see that, for example, the average duration of sleep was more than 8 hours in March, but less than 8 hours in April and May. And yeah, there's so many ways to use this type of application. It's very fun to play around with. I hope you have fun later in the exercise. Then we can transform the values in our data frame. And for this, we need to select the column we want to transform with the projection. So we select a column. And here, what I'm doing is very useful. We had before the duration in seconds, right? But it's not very intuitive how much 34,000 seconds are. So we want to transform this into hours. And we transform seconds into hours by dividing it by 60 by 60. And yeah, it's very easy actually in Python to transform the values. You just pick a column and then you can just add the basic operators like plus, minus, times, or divided by to transform the column. And then you can see in the output that this is the old column and this is the new column we assigned. There's one more advanced transformation which can be very useful. It's the apply function. It helps you to define a function within this function which will be applied to every row in the data frame. So, for example, we can put if statements in there, we can put functions in there, and the keyword that we need to do this operation is called lambda. There's an example below. It's totally fine if you don't understand this right now. I just want to mention it here so you know it exists, and you can test out how it works in the exercise. But let's move on to visualization. And visualization is very easy in Python, especially if we use this library called matplotlib. It's used for But let's move on to data visualization. It's very easy in Python, especially if you use this library called matplotlib. It offers a variety of different plots, and I put some examples of plots here on the slide. That ranges from simple histograms and pie charts to absolutely abstract plots. You can see up there on the right a stream plot. I have no idea what this is, but there's a lot of room for testing out different plot styles. And if you go on the matplotlib website, there will be instructions how to use every single of these plots. And I will also link matplotlib cheat sheets in the end that summarize all of the info I will give you now. So yeah, sky's the limit. They can be interactive, they can be in 3D, they can be dynamic. Yeah, let's look into it. Matplotlib, it's the same as before. With the pandas, you need to install the package on your computer first. This is done in the terminal. And then you load matplotlib, specifically the pyplot library, into your notebook. We do this by calling import matplotlib.pyplot as PLT. So PLT here is the common nickname we use for this library. And it's easiest for you to stick with this nickname if you want to copy and paste code from your Google searches. So I highly recommend using the PLT nickname. And I would say we jump right in and create our first plot. Let's do the very basic plot using the sleep duration. So basically, we just type plt.plot, open bracket, sleep. Then we select the column that we want to plot. Here we choose the duration. Then we close the bracket. And then in another line, we write plt.show, open bracket, close bracket, to give our plot as an output. And here we can see the varying sleep duration over the 3 months. Wow, it's very inconsistent, but it's also, the plot still looks a bit messy. I don't know if you agree. The x-axis looks a bit messy. And this is definitely enough code to do a basic plot. But once we get a bit more advanced in matplotlib, we can make more pretty plots. And I'll show you on the next slide how that could look like. So here we can add a title to our plot. We can add axis labels. We can also edit the axis ticks. So for example, on the x-axis, we had a huge mess before with too many dates. But this way, we're only adding some of the x-ticks, and it looks a bit nicer. Then we edited the format of the plot, so it adds, so it's wider and can show the timeline better. And also we added one line that is called plt.savefig. which helps us to save the plot as a PDF or as a PNG, whatever you need. You just define the file name in the parameters of the function. Yeah, and just for you as a comparison, it can be as easy as this, but to make it nice, it also can be a couple of more code lines. Yeah, so these are like the basic style elements, title, labels, and ticks. And now we will look at different different types of plots. So one different type would be the scatter plot. Here, instead of having a line that connects those points, we just have the points scattered in our plot. So here we need 2 parameters in the scatter function, and the first one will be the data presented on the x-axis, and the second one the data on the y-axis. So here you can see the duration of sleep by the amount of deep sleep. This is already a great plot to see patterns within the data. And yeah, that's about the scatter plot. We can also create groups within the scatter plot. So here you can see the different months in different colors within this plot. Another plot is the bar plot. We call it by typing plt.bar. Here we first need to create a grouping of the data. So exactly what I showed you just a few minutes ago, this type of aggregation where you first group by a column and then aggregate by any aggregation function. So here we have the mean duration of sleep within a month. And here we can see that the March is slightly higher than the April and May. Then we can do a pie chart. Okay, so the values for the size slices need to be given in a list. So here we can also use the aggregation function. Then we can create a histogram. So this shows the distribution of the values within a variable, or here in a selected column. Here we see the distribution of deep sleep. So here we just type plt.hist, open the bracket, and then put in the column that we want to visualize. So, and this is the cheat sheet I promised. This is an overview of the different plots and the parameters to make the plot more fancy. So as I said before, no one knows all of this by heart. If you create a plot, you will need to check the Matplotlib website for the instructions, and that's totally fine. And these cheat sheets can be useful to access this information quicker. So here's one about the different types of plots. And then here is another one. I put a link here, then you can also download them from the website in high quality. It's very useful to have them saved somewhere where you can access them quickly when you're creating plots. Okay, again, we have a Jupyter notebook where you can test it out on the sleep data. We have some exercises here, how you can create, where we ask you to create different plots, but also we have all the code for the plots that I presented to you earlier, so you can copy and paste this and adjust it to however you need to change it to make a new plot. So yeah, please look into the exercise, it's really helpful. You might have learned a little bit now listening to me here, but you will learn a lot more by testing it out yourself. And now the last part of the session is how to do machine learning in Python. So we have a package for that. It's called scikit-learn. It's a library for predictive data analysis. It has all kinds of tools. So I showed you this plot in the last session with the different fields of machine learning. And it has functions for applying all of these different classifiers or clustering methods. It has functions for pre-processing. For a Python beginner, it's really all you need to dive into machine learning. And yeah, same as before, you need to download the package scikit-learn. It works exactly the same way as with Matplotlib and Pandas. And now we will go through this step-by-step guide again, looking at the different steps and then looking at the code that we need to execute those steps. So with selection, I'm basically meaning loading the data, selecting the data you need for the machine learning model, understanding the data, and part of this can also be understanding what the columns mean, understanding what is useful for your machine learning model, what is not, understanding what needs to be pre-processed. So here in the selection part, make sure that you get the right data for your machine learning model. And yeah, loading it into Python and having a first look at it will be very useful. Second part is the pre-processing. So there are some pre-written functions to do those types of pre-processing steps that we talked about in the last session. So for example, the label encoding, there is a function called label encoder. You need to load it from the scikit-learn package. Then you call the pre-processing package dot the function you need, the label encoder, and then you apply this function. Again, it varies a bit from function to function exactly what parameters you need and how you apply it. Please check the scikit-learn website for every function that you want to use if you're not sure how to use it. Here we can see how to do the scaling. We load the min-max scalar from the Python package as from scikit-learn preprocessing. Then we call the min-max scalar function. Then we say on which column we want to scale or which data frame we want to scale. And now we would look at the transformation. This is how we split a data frame into train and test set. We import the train test split function. And then what might seem a bit strange, we define 4 new variables and we call them xtrain and xtest. X in this case refers to our data and Y in this case refers to the prediction target. So we define 4 variables, xtrain, xtest, ytrain, and ytest equals train test split. And we do this because the function train test split outputs 4 new variables. Okay. There are different parameters in the train test split function we need to define. One of them is our data. One of them is the target label. One of them is the split ratio. So here we give the size of the test set, which in this case is 20%. And then if you remember the slide about stratification from the last session, we also want to stratify the split by the classification target. Okay, so this is the blood donation example. Here we want to have an equal amount of people who donated and who did not donate in all of these different splits. Okay, that's that. And now you will be surprised because I did tell you last session that 80% of the work lies in the pre-processing steps and only 20% of the work lies in the actual data mining. And now you will see why. Because this is all the code you need to run a basic classifier. So these are the 2 examples that we talked about in the last session, the k-nearest neighbors and the decision tree. And all we need to do for now is importing the function, which is called, for example, k-neighbor classifier. Then we can give this then we can put this function into a variable. We often call this variable CLF for classifier, but you can be creative here. Then we assign parameters to the classifier. So if you remember, K was our parameter to decide how many neighbors we look at in the classification. So we say n_neighbor is equal to 3. And then we derive the model. We do this by taking this variable that we defined earlier, which is called CLF, dot fit. So we call the function fit on this model. And fit means we do the training process here. For the training, we need the training data and the training labels. So xtrain and ytrain. Those are the two parameters we need in this fit function. And then we can do the classification. We define a new variable, which is called ypred commonly. It's the predicted labels, and we assign to this variable of predicted labels the output of calling the predict function on our classifier. So we predict the labels for xtest. Xtest is the data in our test set. So the model that we learned, it's trained and saved in the CLF variable, will now be used to apply the predict function and create a new variable that is called ypred, which has as a content the different labels that we predict. And if we print ypred, you can see that there's a prediction whether a person is a blood donor or not in every element in this list. So all of these ones and zeros are people within the data set, and if it's a 1, we predict that this person in the data set has donated, and if it's 0, then we predict that the person in this place has not donated. So that's basically all about it. I will just summarize this quickly. We need to import a classifier. We assign this classifier with the parameters we need to a variable. Then we call the fit function on this variable to train the model. And then we call the predict function on this variable to make a classification. Okay. Once again, you will test this out in the code. And now as a last step, we will look at the evaluation of this classifier. So you remember that we typically use a confusion matrix to evaluate a classification. And I have explained in the last session how a confusion matrix works. And now you have the code on how to build one. So we first import the package for the confusion matrix. Then we create the matrix. So we calculate the true negatives, false positives, false negatives, true positives. And then we plot this matrix. There is a specific plotting function only for confusion matrices. You can use it there. It's very simple. Okay, and then there are also different functions to calculate the metrics we have learned about. So we import from scikit-learn.metrics the function accuracy score, and then we just call the function accuracy score and fill in the parameters. So the parameters we need are ytest and ypred, so the true values and the predicted values, and this function will compare both of them and return the accuracy value. The same holds for precision, recall, and the F1 score, as you can see below. Okay, so you will get, once again, the blood transfusion example to test it out. You can also test it out with the sleep data set that is linked. And now, to wrap up the session, we will look at a coding project with real data. So when you are done with all of the exercises going through the Jupyter notebooks. There will be a project with different type of data, and it will be cancer cells. So about the case, we can create a machine learning model that classifies cancer cells or as benign or malignant based on different features. So the columns in this dataset are features of a cancer cell, and every row in the dataset refers to different cancer cells. And yeah, you can see the notebook here. The data will be in there, and what we ask from you in this project is to just repeat the steps you have learned in the exercises before, just on a different data set. And what you will do there is load the data, understand the data, make first analysis of the data, plot the data, and then in the end, combine all of this in a machine learning model. So thanks for these sessions. I hope you got a good impression of Python, and you don't need to be Python masters by now, but this will give you the fundamental knowledge you need to start learning Python by yourself. Because no one is a Python expert from the start, you need to learn how to Google the things you need to know, and then you will get there step by step. I hope the exercises will help you, and I hope you will have a good time solving your first machine learning project in the coding project. Thank you.